Combinations. So where combinations really vary from permutations is in combinations, order does not matter. Okay, so for my combinations, order does not matter. Again, we can look at this expansion right here, and I'll get to that when I get to the algebra problems with this. If you look on your calculator, again, under math probability, you'll see the NCR button, which works the exact same way as NPR. And you can also see that we have this cool, funky way of writing it. Now, with combinations, since order doesn't matter, we're just looking for groups of things, we again can get this expansion right here, but I will get to that when we get to the algebra of this, which will be after we finished all of the word problems. So, example 1. 3 students from a class of 10 are to be selected to go on a school trip. How many ways can they be selected? So, combinations actually are a lot less complicated than permutations are, even though the expanded form looks more complicated. We have a class of 10 kids, and we want to pick a group of 3. Now, the big thing with this is it doesn't matter the order that I pick the group. All that matters is who's in the group. So order does not matter, which means I'm just going to go 10, choose 3. I have 10 people, and I'm picking 3 of them to be in my group. And that gives me 120 ways. In Lotto Max, a player chooses 7 numbers between 1 and 49 inclusive. How many different tickets are possible? So I have 49 numbers, and the order doesn't matter, so I choose 7 of them. And that gives me a really large number. So about 85,900,584. If you want something to do for fun, the probability that you win the big prize would be 1 over that. So basic combination questions are pretty easy and pretty straightforward. Now what we're going to do is we're going to get into subcommittee questions, and you know what? These actually aren't that bad either. So just sort of bear with me. So a subcommittee of 5 people is to be formed from a group of 15 members, and there's going to be 8 males and 7 females. How many subcommittees are possible if? So if there's no restrictions, basically all that will mean is I have 15 people and I want a subcommittee of 5. So I would just simply type in 15 choose 5, and that gives me 3,003. Now let's say we want exactly 3 females. Well, there's 7 females, and I want to choose 3 of them, but that leaves me 2 members of the committee to be chosen from the males. So I'd have to multiply that by 8 choose 2. Again, what's going on right here is we want exactly 3 females, so that's going to give me the 3 from the 7. Then from there, we still need to fill up the group with 2 more members, so that will give me the 8 choose 2, which will end up being 980. Let's say 3 males and 2 females. Well, my 3 males would be 8 choose 3, and my 2 females would be 7 choose 2. So this one would just simply be 8 choose 3. And then I'd multiply that by 7 choose 2. And this will give me 1,176. No males. Well, no males would mean that my entire group would be female, so that'd be 7 choose 5. Now I could multiply this by 8 choose 0, but 8 choose 0 just equals 1. So we could just get away with going 7 choose 5, which gives me, 21 different ways. Now, at least 4 males. At least 4 males gets a bit more complicated. So at least 4 males would mean that I could have 4 males, not males, males, or I could have 5 males. So 4 males would be 8 choose 4 multiplied by 7 choose 1. Because what I'd have right there is I'd have the 8 males and I'd be choosing 4 of them. And then I would have to just multiply that by the 7 females that I'm choosing 1 of. But I could also have 5 males. So my 5 males would be 8 choose 5. Now, what are we going to do? And this is a separate case question, so I'm going to add these two possibilities. And ever so quickly, that gives me an answer of 546. At least 3 females. So at least 3 females would be 3 females, 4 females, or 5 females. So my 3 females we had from before, which was just 7 choose 3 times 8 choose 2. 4 females would be 7 choose 4 multiplied by 8 choose 1. And my 5 females would be 7 choose 5. And again, I'm going to add these together. Now we could just kind of speed through this because we have 2 of the answers above. And then all that we'd have to do is add the 7 choose 4 times the 8 choose 1 onto that. And this would give me 1,281 ways. Joe, the eldest member in the group, must be included. So, if Joe must be included, what that effectively means is he's going to stay and he's going to be on the committee. That has now reduced me to 14 people, and I have 4 options left for those 14 people because I've already dictated that Joe is on the committee, and this would give me 1,001. Dave and Bob cannot both be on the committee. So from here, we'd have the number of ways that David is on. And the number of ways that David is on would be 1 multiplied, but if Dave's on, Bob cannot be on. So that reduces us to 13 choose 4. Because I cannot have Bob on the committee if Dave is on it. So it reduces my total number to 13. And that would give me 715. Or we could have Bob on, and that actually works out to be the exact same way. Bob is on the committee, but from there, since Dave cannot be on the committee, we've reduced 1 person from that, so it would just be 1 times 13 choose 4, which would be 715 again. So adding these 2 together would give me a total of 1,430 ways. David or Bob must be on the committee. Now, this one kind of puts us into a funky mathematical thing. There's actually 2 ways that we can look at it. We can look at it where Dave is on, Bob is not, Bob is on, Dave is not, or both Bob plus Dave are on. Okay, so when we use the mathematical word or, a lot of times it insinuates that they can both be on the committee as well. On any assignment that you guys will get, it will be stated very, very clearly if that is the case. So we have Dave is on, Bob is not, and again, that would give me the 715 from above. Bob is on, Dave is not, which would give me the 715. And then we'd have to add that both Babe, Bob, and Dave are on the committee. So if Bob and Dave are on the committee, that would be 1 multiplied by 1, because Bob and Dave are on, order doesn't matter. And then I'd have 13 people left, and I'd need to choose 3 of those people. So we just get the 13 choose 3 right there, and that would give me the 286. And that would give me a total of 1,716 different ways. Consider a class of 30 students. Now this question is going to show us kind of the difference between permutations and combinations. So if I have 30 students, the class is to elect a 3-member student government. How many ways can this be done if there's president, vice president, and a treasurer? So in this case, order matters, because what's happening is I'm placing people into specific positions. So it's just going to be 30 multiplied by 29 multiplied by 28, or if you will, it will be 30p3. And in total, that would be equal to 24,360 different ways. To contrast that, if it's just to consist of 3 numbers and there's no positions that are being assigned, all I'd have to do is go 30 choose 3, and this would give me 4,060 different ways. Now moving on, we're not going to make you guys have to do any poker hand questions. So anytime you see a poker hand question, those are actually taken out of the curriculum, and we've actually hit the at least and that most in a previous question already. So, and we'll get to this and the algebra in a further lesson.